Hello, this is Aaron Holmberg from Corvallis Middle School, and this video here is about how to borrow when you're subtracting with fractions. These couple fractions here, these mixed numerals, you might be able to notice that the 4 and the 2, that'd be easy enough subtraction, but when you go to take 3/4 from 1/3, well, the 3/4 is larger than the 1/3, so somehow you would have to borrow in there. Like regular subtraction, you're going to borrow from the whole number to make the fraction large enough so that the other fraction can be subtracted from it. And what usually that means is the first fraction is going to have to be changed into a mixed numeral that has the same denominator, of course, but the mixed numeral, it's going to be an improper fraction, I meant to say. And the numerator is going to be large enough that once the denominators are common, you can subtract those two numerators. So I'm going to do a few here, and there may be some steps that I show that I kind of circle with the blue pen, that the steps that don't have to be shown on paper, but they might be thought. So the very first step here is always to make common denominators. So in this case we've got 3 and 4, and the easiest thing to do is just cross multiply those. So we don't do anything to the whole numbers, we leave them be, and just showing students like that's a good way to do it. They're both going to be 12ths, and it's a good idea to teach students just recognize that it's 12th. By doing this, you can relax your brain and think about how's that simply going to change my numerators. So 1/3 would be 4/12, and 3/4 would be 9/12, and that's just by scaling up. And we've studied quite a bit where you do this side times 4, and you do times 4 up here, and you do times 3 down here, and times 3 down here, and you're using different factors on each side, but you're scaling up in both cases so that you have a common denominator. So right here you can see that the 4 and the 9, you're not going to be able to do that subtraction. So thinking about this here, if you make the 4 into a 3, like you're going to borrow, then what you're doing is you're taking a whole number from it. So you took 1 away from it. So this is the step I'm going to show that's kind of like you're going to imagine it. 3 plus 1 would equal this 4 right here. 3 plus 1 plus the 4/12. That's what I have sitting on this side. And those are the same. 4 and 4/12 is the same thing as 3 plus 1 plus 4/12, minus 2 and 9/12. And again, this step right here, I'm going to show how students might think through this, but then on a few of my next examples, I won't necessarily show that step. I'll just say this. You might do this step in your head. So a whole number right here, if you're looking at this denominator, a whole number is going to be 12/12, because my denominators are 12. So if I rewrite this, it's like having 3 plus 12/12, which is this 1, plus 4/12, and you're thinking these things together, minus 2 and 9/12. So you can combine, of course, the 12ths here, and it looks like 3 and 16/12, which is this kind of weird improper fraction inside of a mixed numeral. Don't know if you call that an improper mixed numeral or what that makes sense, but 3 and 16/12 minus 2 and 9/12, and then you do your subtraction. Your whole numbers are going to subtract 1. 16 minus 9 is 7/12, and there's your final answer. So that's one example. I have a few others just to share. And again, these couple steps here that I've just shown are sort of the head steps, and I don't know if I'll show all that in my next example. I'll just say that I did. So here is my next problem I was going to share. 3 and 2/5 minus 1 1/2. And of course, a half is bigger than 2/5, so I'm going to have to borrow to make this work. And if I've got, oh, I messed this one up. I meant to have a half here. I'm sorry. So let's call it 1 1/2. Here, I'll make this much cleaner. Let me start that again. 3 and 2/5 minus 1 1/2. The tenths I was thinking about changing it to. Okay, so first thing is I'm going to just keep the whole numbers the same. I'm going to change to a common denominator, which in this case is tenths. And I multiplied by 2, I multiplied 2 is 4. And multiplied by 5, 5/10 like this. I can't subtract, so here's that step I do in my head. I know it's going to be 2, and a whole number is 10/10. So the 10/10 and 4/10 is 14/10.